Okay, we just had a series of kind of negative videos. They were all about functions that were not continuous and how they could be discontinuous in various ways. But continuity is a nice thing. We want to show that functions are continuous. And so the question is how to show functions are continuous. And we want to do this as easily as possible. So we had a definition. Go back to the definition in the first video that the limit as x goes to c of f of x has to exist, the f of c has to exist, and those two have to equal. But we don't always want to check the function is continuous from the definition every single time we want to do that. And so we want to look for shortcuts. And so we have the following shortcuts. So first thing, the book discusses, I didn't do it in this video, but the book discusses that constant functions are continuous. So for example, if you have something that looks like f of x is equal to minus 4, that's a constant function, that's continuous everywhere. Another thing that the textbook shows is that x to the n is continuous, where n is a positive integer. So earlier we did the special case of x to the 7th. We showed that was continuous everywhere, but there's nothing special about 7 there. X to any positive integer power is going to be continuous. And so we have these two building blocks. So constant functions are continuous, x to the n is continuous, and so we should ask ourselves, how can we combine together these building blocks to get more continuous functions? And so there's a theorem here, theorem 1 in the section, about basic laws of continuity. And it tells you how to combine together functions that you know are continuous to get new functions that are also continuous. And so here's how it goes. If f and g are continuous at x is equal to c, then the following functions are also continuous. So there's going to be 4 buckets that these go into. So the first thing is the fact that you have 2 continuous functions. You can add them together to get a continuous function. Also, instead of adding them, you can also subtract them. So a continuous function plus a continuous function is continuous. A continuous function minus a continuous function is continuous. Second thing is we have a constant multiple rule. Kf is continuous, where k is a constant. So if your function f is continuous, 3 times f is also continuous. Number 3, we have f times g is continuous. So multiplying together 2 continuous functions also gives you a continuous function. And finally, so we can add, we can subtract, we can multiply, so what's going to come next? We can divide continuous functions to get a continuous function. But you should think to yourself, what's the special thing we have to account for? And so the thing we have to account for is that this has to happen as long as g of c is not equal to 0. It's worth noting here that I said if f and g are continuous at x is equal to c, I should have said the following functions are also continuous at x is equal to c. So, and all throughout I should have been saying at x is equal to c, at x is equal to c, at x is equal to c. It's a little bit tedious to say that all the time, so that's kind of implied. Okay, so So we have sum, we have difference, we have scalar, I should say constant multiple, a product law, a quotient law. And so this should all feel very reminiscent of the previous section. And so we'll just say to prove them, you're going to use the basic limit laws.